Hello, I'm Jay Watson with iPhysics, and I'm showing our EP Fasteners and Holes tool, which, if you've installed it right, should be on your Tools menu. We needed a tool that would let us drill threaded holes through solid material that we were going to be printing. We have a Formlabs Form 1 printer. So on the tool you can select metric or American standards. You can do drilled holes, threaded holes, bolts, nuts, and washers. We'll start with the threaded because those are the most interesting. Standard sizes, so 3/8 inch, 7/16, ½ inch. Coarse fine and extra fine. If an extra fine is really not available for that size, we use the fine dimension. And you can have it be a hole of a set distance with a bottom, or a through hole, which will automatically cut and glue itself to both sides. So we'll start with a fixed length, 1 inch. Place it on a surface and it just plugs itself in. See, there's a bottom to it. Threads look well formed. If we select a through hole, the length goes away because it's automatically calculated. And now we're creating a ½ inch hole, but it doesn't know how long to make it yet, so it's just a hole. So we'll start with putting it on top, and it says that it's going to calculate it to be 2.39 inches. And if we look at our components for this model, we find we have a tapped hole of ½ inch coarse with a length of 1, that is not a through hole, a tapped hole 1/2 coarse that is 2.39 inches long, that was a through hole, and a helper for the ½ inch coarse. And the helper is what's creating the second hole. And you can also just pick that up and make another hole. And since we already have an object that's 2.39 inches long, it just uses it. If we pick it up and we place it on a different face, now it has to calculate a new distance, and it came up with 5.75 inches through our model. And it's generating the geometry for that. And it'll add a new component of the appropriate length when it finishes. So now we have a threaded hole with a length of 5.75. That is also a through hole. So we can look through it and see that it goes all the way through to the other side. Has threads the full length. And once again, if we pick up the helper for this size and drill it through, it's able to reuse the component. So it's much faster, and of course we may have intersected one of those other holes if we weren't careful. And if we hide the wall we were looking through, you can see there's the through length with the outside of the threads, and the one that's short which has a bottom on it. Actually, it has well-formed threads all the way to the bottom, unlike a normal tap, which will leave you with a thread or two at the bottom that are only partially formed. So now that we have those, we can go build some bolts, nuts, and washers. We'll switch to metric. So we'll make a fine M8 nut with a washer. And then we'll make an M8 fine 30 millimeters long with a hex head. There's our bolt. I suppose we could mount it on there. You can see it taps out to the outer dimension as it comes to the head, and the inner dimension as it meets up with the bottom on the last thread. Same time, we also make sockets. Might as well add a washer too. If you're going to place one, you should place both. Phillips head screws, and it uses the appropriate Phillips screwdriver tip for the size. So up through around ½ inch, it's 0, 1, 2, or 3, and then it just stays at the biggest size, even though nobody really makes Phillips heads bigger than that. And you can make set screws. Probably wouldn't make them that long though. Let's make it 15 millimeters, just for amusement. I made a model that has inch specifications, so it's converting to inches. Works just as well if you switch from inches to millimeters. And then it just shows it as 15 millimeters. Washers don't apply to set screws, so it doesn't bother. You see we got exactly the same part. But we did end up with two components because they have different specifications in the component list. So each of these came up as a component. Here's our Phillips head, an M8 fine, socket head, set screw, and another set screw. That one's in inches. This one's in millimeters, even though they were the same size. The model information controlled the naming. So hopefully you'll find this useful. I'd appreciate any comments, and if you find that you are using it, let me know. I'd like to see that it's being used. We can add more features to it if you'd like. Didn't see any point until people were using it. And give me some feedback. Thank you.